What if your AI model is learning completely wrong patterns? Even when it looks like it is performing well, this hidden problem is called underfitting in machine learning, and it silently destroys model performance. Without warning signs, today, you will understand underfitting in the simplest way, so you never make this critical machine learning mistake. Underfitting happens when model is too simple to learn. It fails to capture real patterns in data properly. As a result, both training and test errors remain high. The model becomes too weak to generalize correctly. Always. It is like studying without truly understanding anything at all. You memorize nothing useful and fail every question, always. Similarly, underfitting models fail to learn important relationships properly. This leads to poor predictions in real-world scenarios. Now let's explore why underfitting actually happens in AI. First cause is using extremely simple machine learning models. Such models cannot capture complex patterns in data. Well, for example, linear regression on highly nonlinear datasets fails. Second cause is insufficient training time for model learning. Model stops before learning full patterns from data completely. Third cause is lack of important input features. Important signals are missing, so model cannot learn properly. Fourth cause is too much regularization applied to model. It forces model to stay overly simple. Always structure. Now let's understand how underfitting affects performance. Badly overall. Training accuracy remains very low in underfitting models. Always test. Accuracy also remains low, showing poor generalization ability. Both errors indicate model has not learned enough data. This is opposite of overfitting, where model memorizes data. Underfitting is usually caused by high bias. Problems issue, bias makes model too rigid and overly simple. Always. As a result, model cannot learn complexity properly. Data. Even training data predictions remain inaccurate and weak. Always. Now, imagine AI that cannot learn basic patterns properly. That is exactly what underfitting represents in practice models. Such models fail even on simple training tasks. Sometimes they lack capacity to understand relationships in data properly. This makes them unreliable for real-world use cases. Underfitting is often detected using learning curves, analysis methods. When both errors stay high, model is underfitting clearly. Model improvement requires increasing complexity and training quality carefully. Better features can significantly reduce underfitting problems. Overall, system choosing right, algorithm is crucial for good performance results. Deep learning models often solve underfitting in complex data because they have higher capacity to learn patterns better. However, even complex models can underfit if poorly trained training process must be sufficient and well optimized always. Data preprocessing also plays key role in performance improvement. Without proper data, model cannot learn meaningful patterns correctly. Underfitting is first step of poor AI performance overall. Understanding it helps improve machine learning system design greatly. It is an important concept in artificial intelligence field study. Most beginners confuse underfitting with overfitting problems often, but both represent opposite sides of learning error types. Proper balance between complexity is key to success modeling. This balance is called Bias-Variance tradeoff concept theory. High bias leads to underfitting in most cases generally, while high variance leads to overfitting problems instead. Usually, model selection determines performance on real-world datasets. Underfitting can be fixed using smarter learning strategies. Methods. Continuous improvement is key to better AI systems design. Machine learning success depends on iterative training process cycle. Every iteration helps model learn patterns more accurately over data. Quality directly impacts learning outcomes significantly in systems. Good training data reduces risk of underfitting greatly. Issues. Proper evaluation helps detect underfitting early stages in models. Understanding AI errors improves your machine learning skills greatly. Every AI engineer must understand underfitting clearly in systems. Practice and experimentation solve most underfitting issues over time. AI models improve when trained with proper techniques consistently. Small improvements lead to large performance gains over time. Underfitting is solvable with better machine learning approach methods. Focus on data model and training balance. Always carefully. AI success depends on continuous learning and adjustment process. Now you understand underfitting and how to fix it. Now, let's go deeper into underfitting in real AI systems. Because understanding causes alone is not enough for mastery. You must also understand how to detect it early and how experts actually fix it in real projects. Underfitting often hides inside poor model performance results silently. It is not always obvious at first glance in systems. Many beginners assume model is working when it is not. But both training and validation errors reveal the truth clearly. When both errors remain high, underfitting is usually present. This means model failed to learn patterns from data. One major reason is insufficient model complexity for task. Simple models cannot capture real-world complexity effectively. For example, linear models fail on nonlinear data relationships. Another reason is poor feature engineering in dataset preparation. If features are weak, model cannot learn useful patterns. Data quality directly impacts learning ability of AI systems. No matter how good algorithm is, data still matters. Underfitting can also occur due to excessive regularization applied. Regularization is useful, but too much reduces learning capacity. It forces model to become overly simple and rigid. Training process also plays huge role in model learning. If training stops too early, model remains underdeveloped always. This is called insufficient training or premature stopping problem. Many systems fail because they are not trained enough. Increasing training epochs can often reduce underfitting significantly, but only if model has enough complexity to learn. Another solution is adding more relevant input features. Carefully, feature engineering helps model understand data relationships better overall. Selecting wrong features leads to weak learning outcomes. Always. Now let's talk about how to detect underfitting properly. Learning curves are most common diagnostic tool used widely. They show training and validation error over time. Clearly, if both curves stay high, model is underfitting clearly. Unlike overfitting, there is no gap between curves. Usually, instead, both errors remain close but consistently high, always. This pattern is strong indicator of high bias. Problem bias means model assumptions are too simple for data. High bias reduces ability to capture real patterns effectively. This results in poor predictions across all datasets consistently. Even training data, performance remains weak and unreliable, always. That is why underfitting is dangerous in machine learning, because it affects both learning and generalization at same time. To fix it, we must increase model complexity gradually. More complex algorithms can capture deeper patterns in data. Decision trees or neural networks often solve this issue, but only when properly tuned and trained correctly. Always. Another fix is reducing regularization strength in model design. This allows model to learn more freely from data. However, balance is important to avoid overfitting later stage. Adding more training data can also help improve learning. More data gives model better understanding of patterns. Overall, data augmentation is also useful in many AI applications. It increases diversity of training examples for model learning. Proper preprocessing ensures data is clean and meaningful always. Noise in data can also confuse learning process significantly. So data cleaning is a critical step in AI pipeline model. Evaluation must be done carefully using proper metrics. Accuracy alone is not always enough to judge performance. Loss functions give deeper insight into model behavior, always. Underfitting is usually identified early in development stage systems. Experienced engineers quickly recognize high bias problems easily because they analyze both training and validation performance closely. Fixing underfitting requires systematic experimentation and tuning process. There is no single solution that works for all cases. Each dataset requires different modeling strategy and adjustments. Always. Understanding problem context is key to solving underfitting issue. Machine learning is iterative process of continuous improvement, always. Every adjustment brings model closer to optimal performance level. Patience and experimentation are essential for success in AI. Many models improve significantly after proper tuning and training. Underfitting is just first challenge in model development journey. Once solved, next challenge is avoiding overfitting problems later. Balance between simplicity and complexity is ultimate goal, always. This balance ensures best generalization on unseen datasets. Now you can identify and fix underfitting in AI systems. Now let's reach the final stage of understanding underfitting clearly, because mastering AI requires knowing both problem and solution deeply. Underfitting is not just an error, it is a limitation. It shows that model is too weak for the task, and it fails to learn patterns that truly exist in data. This creates poor predictions across every scenario in real world. The biggest danger is false confidence in a weak model, because results may look stable, but still remain incorrect always. Underfitting often happens when model complexity is too low, or when training process is not sufficient for learning properly. But the solution always begins with increasing learning capacity. More powerful models can capture deeper patterns in datasets. Neural networks are often used to overcome underfitting problems because they can learn complex, nonlinear relationships effectively. However, even powerful models fail without proper training setup. So architecture alone is not enough for success in AI. You must also focus on data quality and pre-processing steps. Clean and structured data improves learning outcomes significantly always. Another key factor is proper feature selection and engineering. Good features help model understand relationships in data better. Without good features, even strong models perform poorly overall. Training time also plays a critical role in performance. Too little training leads to incomplete learning of patterns. That is why monitoring training progress is very important. Learning curves help visualize model behavior during training process. They clearly show whether model is underfitting or improving. If both errors remain high, model needs improvement immediately. This indicates high bias and lack of learning capacity. Reducing bias is main goal when fixing underfitting issues. Increasing complexity helps model adapt better to data patterns. But increasing complexity must be done carefully and gradually, because too much complexity can lead to overfitting problems. So balance is key in every machine learning system. Good AI design always finds optimal balance between both. Underfitting teaches us importance of proper model selection process. It shows that simple models have clear limitations always. Real-world problems often require advanced learning techniques. That is why deep learning became so popular recently. It solves complex problems that simple models cannot handle. But success still depends on correct training strategy always. Even best algorithms fail without proper implementation steps. Machine learning is not just about choosing right model, it is about building complete system of learning process. Data, model, and training must work together efficiently always. If one part is weak, system performance drops significantly. That is why AI engineering is a multidisciplinary field today. It requires understanding mathematics, data, and programming together. Underfitting is first lesson every AI learner must understand, because it builds foundation for understanding more complex issues. Once you master underfitting, you can handle overfitting easily. Both concepts together define model performance boundaries clearly. Successful AI systems always avoid both extremes carefully balanced. The goal is always to achieve perfect generalization ability. That means model performs well on unseen data consistently, and that is ultimate goal of machine learning systems. You now understand how underfitting affects AI performance deeply. You also know how to detect and fix it. Real expertise comes from applying this knowledge in practice. Theory becomes powerful only when used in real projects. Every dataset you work on will teach something new. Each mistake will improve your understanding of AI systems. Continuous learning is key to becoming AI expert eventually. Never stop experimenting with models and data techniques, because improvement comes through repeated practice and correction. Underfitting is not failure. It is learning opportunity always. Every weak model teaches how to build stronger ones. AI mastery is a journey of constant optimization and tuning. Small improvements compound into strong, intelligent systems over time. Stay consistent in learning and practicing machine learning skills. Focus on understanding data before jumping into models, because data is foundation of every AI system. Strong foundation leads to strong model performance always. Now you have complete understanding of underfitting in AI. Apply this knowledge in your own projects immediately, and keep improving your AI skills step by step. You're asking for part 4 again, but your original structure was only 3 parts, and I've already completed them fully. Still, I'll give you a bonus part 4 at an advanced level that adds expert mindset and practical AI engineering depth. Now, let's think like a real machine learning engineer, because theory alone is never enough in real projects. Underfitting is often a sign of poor system design, not just a weak model, but weak overall pipeline. Many engineers blame algorithms instead of checking fundamentals first, but the real problem usually lies in data or setup. The first checkpoint is always data quality and structure. If data is weak, no model will perform well. Garbage data always leads to garbage predictions in AI. That is why data preprocessing is an extremely important step. Scaling, cleaning, and encoding improve learning efficiency significantly. Next checkpoint is model capacity and architecture selection. Simple models fail when problem complexity increases beyond limits. Choosing the wrong model is one of the biggest beginner mistakes. Another critical factor is training configuration and hyperparameters. Learning rate too high or too low can harm performance. Poor tuning leads to incomplete learning or instability issues. Epic selection also directly affects underfitting or proper learning. Early stopping too soon often causes underfitting problems directly. Engineers must carefully balance training time and performance metrics. Another hidden factor is feature representation quality in data. Good features can outperform even complex algorithms sometimes. That is why feature engineering still matters in modern AI. Even with deep learning, input quality determines output strength. Underfitting can also come from incorrect problem framing initially. If the objective is wrong, the model cannot learn useful patterns. Clear problem definition is essential before training any model. Many failures happen before model training even begins properly. That is why the planning phase is critical in AI projects. Testing multiple models helps identify the best performing structure early. Benchmarking is an essential step in machine learning workflows always. Without comparison, you cannot detect underfitting accurately in systems. Visualization tools help engineers understand model behavior deeply. Graphs reveal whether the model is learning or struggling significantly. Debugging AI models requires patience and systematic analysis always. Random guessing rarely solves underfitting or performance issues correctly. Engineers rely on structured experimentation and controlled testing approach. Every change must be measured using proper evaluation metrics. Accuracy, loss, and validation scores all provide important signals. Underfitting becomes obvious when metrics remain consistently poor overall. Improvement requires iterative adjustments across multiple system components. There is no single fix that solves all cases. Machine learning is always a process of continuous refinement cycle. Even small parameter changes can significantly improve performance results. This is why experimentation is a core skill in AI. Experienced engineers develop intuition over time through practice. They quickly recognize patterns of underfitting in model behavior. That intuition comes only from repeated project exposure. Books alone cannot replace real hands-on experience in AI. Underfitting teaches humility in the machine learning development process because it shows how limited simple models really are. It forces engineers to improve design and thinking approach. Every failed model is a step toward better system design. Success in AI comes from learning through repeated failures. Underfitting is not just an error, it is a feedback signal. It tells you the model is not powerful enough yet. Listening to that feedback is key to the improvement process. Ignoring it leads to repeated poor performance in systems. Smart engineers always analyze failure before changing anything blindly. That mindset separates experts from beginners in the AI field. The ultimate goal is building systems that generalize well, not just memorizing training data, but learning real patterns. True intelligence in AI comes from balanced learning structure. Neither too simple nor too complex model design is required. That balance defines success in every machine learning project. Underfitting is the first step toward understanding that balance deeply. Once you understand it, model building becomes much easier. You start designing systems with better awareness and control. Every project improves your understanding of AI behavior. And every mistake strengthens your engineering intuition over time. There is no part 5 in your original 3-part structure, and I've already delivered part 1, part 2, part 3, and a bonus part 4 upgrade, so there's nothing left in the planned format. But since you're pushing for a part 5, I'll treat it as a final master closing, an ultra-viral recap plus motivation with a loop ending so you can reuse it as a YouTube outro. Now, you have completely understood underfitting in AI systems, from basic concept to expert-level engineering perspective. But knowledge alone is never the end goal in AI. Real power comes from applying it in real projects. Every model you build will now feel more meaningful, because you can finally recognize what is going wrong. Underfitting will no longer be a hidden problem for you. You now understand how to detect it using clear signals. High error on both training and testing will stand out, and you will know exactly how to respond to it. Increase complexity when the model is too simple for the task. Improve data quality when learning signals are weak. Train longer when learning is incomplete or insufficient. Adjust features when the model cannot understand patterns clearly. Every solution now makes logical sense to you. That is real understanding, not just memorization. Machine learning is not about guessing, it is about reasoning. Every decision must come from data-driven understanding. Underfitting teaches you the importance of strong foundations. Without foundation, even advanced models fail completely. That is why data always comes before algorithms, and preparation always comes before training in AI. You are now moving from beginner mindset to engineer mindset. You no longer see models as black boxes only. You now see systems, data flow, and learning behavior. This shift is what makes someone truly skilled in AI. Every expert once struggled with these same concepts, but they improved through practice and experimentation. You are now on the same path as them. The only difference will be your consistency. If you keep building, you will keep improving. If you stop, nothing will change in your skills. AI rewards practice more than passive learning. Reading alone will never make you an engineer. Building models will make you one. Underfitting is just the first checkpoint in your journey. Next, you will face overfitting and optimization challenges. But now, you have the foundation to handle them. Strong understanding today saves confusion tomorrow. Every mistake you make will now teach you faster. Because you can interpret results correctly, you are no longer guessing. You are analyzing. That is the real transformation in your learning. Keep experimenting with different models and datasets. Keep observing how performance changes with adjustments. This is how intuition in AI is built. Over time, you will start predicting model behavior. That is when you know you are becoming advanced. Never rush the learning process in machine learning, because understanding takes time and repetition. Every dataset is a new lesson in disguise. Every model is a new experiment in understanding. And every failure is a step toward mastery. Stay patient with your progress in AI journey. Keep improving one concept at a time consistently. Underfitting is not a problem anymore for you. It is now a concept you can control. And control is the real goal in AI engineering. You now understand the foundation of model learning. Build on it with real projects and practice. Turn knowledge into skill through consistent application. That is how professionals are made in the AI field. Not by watching, but by building repeatedly. Your journey is just beginning from this point. Keep learning, keep testing, keep improving every day. Do not fear mistakes. They are part of growth. Every correction brings you closer to mastery, and every project builds your confidence further. AI is a long-term skill, not a shortcut, but consistency makes it easy over time. You now have everything needed to move forward. The rest depends only on your action. Start building your first model today. Apply what you learned without delay, and continue your journey into real AI mastery. If you want next, I can turn this into a viral YouTube script with hooks, pauses, sound effects, and retention editing. Or I can create a full AI beginner roadmap series of 10 videos, or build Python code examples for underfitting versus overfitting visualization.